Hello everyone, my name is Jacob Balagasao, and today our group is going to discuss about chapter 2, which is all about the designing of the highway. So this presentation is brought to you by our group, Blacklist, and the members are Jacob Balagasao, Luigi Niquefado, Serafin Baldwin Kifo, Mahinay Carlito Jr., and John Gabriel Guilon. So let's get started. Consistency. Consistency is the most important single rule in the highway design. That is, by making every element of the roadway conforms to the expectation of every driver. Among the promising approaches to improve the highway safety performance is the concept of the highway design consistency. Drivers expect the highway agency to provide them with clear information and guidance through a variety of road signs and avoiding abrupt changes in the traffic as well as the road standards. If these guides and direction can be planned properly to convey one single message at a time, and if these directions will be followed smoothly and easily with undue haste or changes in speed, then the roadway facilities are considered satisfactory. Experienced highway engineers recommended that highway signs and directions should be integrated as early as preliminary layout studies. AASHTO, or is the American Association of the State Highway and Transportation Officials. In 1914, the American Association of State Highway Officials, or you can call it AASHO, was established as an association of state, territorial, and District of Columbia Highway Department and the Federal Highway Administration. The name was expanded in 1973 when the Department of Transportation was integrated into association, renaming AASHO to AASHTO, giving the officials of this agency the power to govern its operation. Engineering activities were implemented by standing committees with the task of preparing specifications, manual, and standards representing the current highway engineering practice. And AASHTO publication includes transportation, materials, specifications and test, specifications for highway bridges, geometric design standards, and numerous policy statements and guides. AASHTO publications are authoritative, meaning they are reliable. So all the information that the AASHTO published are accurate or true. Reference are made in these books and periodic manuals. The association also publishes the AASHTO quarterly reports on current highway and transportation subject, including trends in forecast and legislation. Roads and highways. Roads and highways are defined as strips of land that have been cleared and further improved for the movement of people and goods. Road. Road has somewhat broader application in usage while generally used to describe a public thoroughfare, or it can also referred as railways. Highways. The term was first used in England to describe a public road, the road built by digging ditches on both sides and heaping up the earth in the middle, creating a way higher than the adjacent land. So basically, it is a major road or bigger roads, usually in rural areas. Highway now connotes a higher state of development than road, but the words are almost interchangeable. Expressway. Expressway is a divided arterial highway for through traffic with full or partial control of access, and is generally provided with grade separation and major intersection. Freeway is an expressway with a full control of access. Control of access is a condition where the rights of owner or occupants of adjoining land or other persons' access to light, air, or view in connection with the highway are fully or partially controlled by public partially controlled by public authority. A controlled access highway is a highway designed to allow traffic to safely travel at a fast speed. So there are two types of control of access, which is the full and a partial control of access. Both of them has the authority to control access and exercise to give preference to a through traffic by providing access connections to selected public roads. But the only difference is that crossing at grade or direct private driveway connection is not permitted in full control of access, while in partial control of access, the control at the crossing of grade and private driveway connections are allowed. Through street or through highway. Every highway or portion thereof in which vehicular traffic is given preferential right of way and at entrance to which vehicular traffic from intersecting highways is required by law to yield right of way to vehicles on such through highway on obedience to either stop sign or yield sign erected thereon. Parkway. Parkway is an arterial highway for non-commercial traffic. So it is a wide road usually divided with an area of grass and trees on both sides and in the middle. Arterial street. Arterial street is an arterial route that carries traffic to the nearest access point or through traffic. It often serves as the most advantageous route for relatively long distance travel. So it is a road without controlled access that can carry a large volume of local traffic at a generally high speed, being below controlled access highway in the hierarchy. So these are the basic considerations in planning arterial roadways. First is the selection of the routes, studies of the traffic volume, origin of the destination, accident experience, width should not be less than 15 meters, must carry at least one lane of traffic in each direction, should be at least 1 kilometer in length, should skirt neighborhood areas rather than penetrate them. On grids design system street, arterials are spaced at about 600 to 900 meters apart, and where accident hazard is not a factor, the minimum volume to justify arterial road is 300 vehicles per average hour during the day and 450 vehicles hourly during peak periods. And sometimes peak periods volume on designated arterial road exceeds the capacity of a two-way street. And to increase the arterial capacity, the following solutions are enforced. During peak hours, parking is prohibited on one or both sides of the streets. Parking is prohibited several meters away from each side of the road, intersections, or corners. Right turn is allowed on red signals anytime with care. Left turns are eliminated to congested intersections, and the direction of the traffic is reversed in a center lane to provide more lanes in the direction of heavier traffic flow. Collector streets. Collector streets form a smaller mesh grid pattern where passengers are picked up from service streets and carried to the arterials. So more like sumpay ni siya sa arterial roads or like a street padong sa arterial roads. So local road. Well, local road is defined as a street or road primarily for access to residents, business, or other adjoining properties. It is also defined as a road constructed and maintained by a local government. So it also refers to streets or roads na mo-accept og traffic from collector road streets or collector road or streets and distribute the traffic through subdivisions, neighbors, and business areas. So highway capacity. Highway capacity is defined as the minimum number of vehicles that are reasonably expected to pass to a given point over a given period of time, usually expressed as vehicles per hour. So under ideal conditions, one freeway lane can accommodate about 2,000 passenger cars per hour, and a two-lane road can carry up to 1,000 passengers cars per hour in each direction. So there's an obvious relationship between vehicle speed and highway capacity. As the volume of a traffic approaches capacity, the average speed is markedly reduced. Average annual daily traffic, or AADT, refers to a traffic volume or flows on the highway as measured by the number of vehicles passing a partial station during a given interval of time. It is also called average annual daily traffic if the period is less than 1 year. Volume may be stated on hourly observed traffic or estimated 38-hour volume commonly used for design purposes. This is determined by counting the total number of vehicles to cross a point in both directions on a highway during a year, and divide this value by the number of days in a year. So 365 days it divides, yeah. So next is the design speed. There is no single set of geometric standards that will apply to all highways. For every highway segment, decisions regarding appropriate control for each of the many details or requirements must be addressed individually or separately. Ashton defined design speed as the speed determined for design and correlation of physical feature of a highway that influence the vehicle's operation. It is the maximum speed that can be maintained over a specific section of the highway when weather and traffic conditions are so favored that the design features of the highway govern. So, basic design features refers to the tightness and super elevation of curves, the sight distance, and the grade. So the design speed is basically higher than the anticipated average speed. And Ashton recommended that the design speed to be set to the greatest degree possible to satisfy the needs of nearly all drivers, both today and throughout the road anticipated life. For economic reasons, the geometric features of a certain road sections are designed for speed from 30 to 50 kilometers per hour. Selection of the proper road design speed is one of the most important decisions to make because it sets the limit to curvature, sight distance, and other geometric features. But because of the limited funds, there is a strong temptation to reduce the design speed. And this kind of decision is very unwise because the alignment grade and sight distance up to the roadway has been constructed and paved along the landscape and right-of-way became more difficult and expensive to adjust or to correct. The Ashton practices is to classify first the highway as rural or urban, and then as freeways, arterial, and collectors and local. Rural collectors and local facilities are classified as flat, rolling, or mountainous, although the design speed presently used is 80 kilometers per hour. Highway designers projected design speed up to 120 kilometers per hour to guarantee against future obsolescence as well as the increased margin of operating safely. The high-speed road design must anticipate future generation high-speed vehicles and advanced transportation system that may operate on many of these road alignments. Although the design speed of most highways is governed by construction costs, the concept of the relatively high design speed for freeways is regardless of cost. So they are planned for a national high-volume traffic and high-speed network. So next is the cross-section of typical highway. The cross-section of a typical highway has a latitude of variables to consider, such as the volume of the traffic, character of the traffic, speed of the traffic, and characteristics of motor vehicles and of the drive. Highway design usually adopted cross-section that is uniform in thickness from end to end of the improvement. This is acceptable on high-volume traffic road facilities, but for a low-volume traffic facilities, modifications of the features like shoulder width, in rough areas are usually employed to reduce cost. So a cross-sectional design generally offers the expected level of service for safety. And recent studies showed that a 70.20 meters wide pavement has 18% less accident compared with a pavement narrower than 5.50 meter wide. And a 7.20 meters wide pavement has 4% fewer accidents than a 6 meters wide paved roadway. Accident record shows no difference between 6.60 meters and a 7.20 meters wide pavement. For the 6 meters, 6.60 meters and 7.20 meters wide pavement with 2.70 and to 3 meters wide shoulder, recorded accident decreases by 30% compared to 0 to 0.60 meters wide shoulder and 20% compared with a 0.90 to 120 meters wide shoulder. It appears that the above difference in accident potential may not justify higher standards, particularly when traffic volume is low. So, originally, the total surface width of the roadway was only 4.50 meters, but due to the increased number of vehicles using the roadway, the width was adjusted to 4.80 to 5.40 meters. So from 4.50 meters adjust to 4.80 to 5.40 meters. So, and lately, the width of the road was standardized to 3 meters for first-class paved one-lane highway, and now 3.60 meters wide surface was adopted standard for freeway and other major traffic roadways, although there are strong demands to increase it further from 3.60 to 4.20 meters. For two-lane rural highways, a 7.20 meters wide surface is required for safety clearance between commercial vehicles and recommended for main highways. So in any example, sa cross-sectional of a typical two-way lane highways, a 7.20 meters wide surface is required for safe clearance. And for collector roadway, 6 meters wide surface is acceptable only for low volume traffic, including few trucks traveling thereon. And for local rural roadway, the minimum surface width is 4.80 meters for a 30 km per hour design speed. And for urban roadway, the minimum design width is 3.60 meters, although 3 meters is also allowed where space is limited. So these are the cross-section of a divided highways where the design speed is less than 100 kilometers per hour. And this is the undivided highways for design speed less than 60 kilometers per hour, 80 kilometers per hour, and 100 kilometers per hour. Next is a road shoulder. Road shoulder or verge is defined as that portion of the roadway between the edge of the traffic lane and the edge of the ditch, gutter, curb, or side slopes. So, kay bao naman tani sa road shoulder kay katuning kilid sa mga road. So, kasagaran road kay naman ay white strip line. So, dira, kilid sa white strip line mo na ang shoulder road. So, the importance of road shoulder. Road shoulder serves as a place for vehicles to stop when disabled or for some other purposes. Road shoulder should considerably reduces road accidents. The road capacity is decreased and accident opportunity increases if the shoulder is too narrow or nipis or omitted in the design. Shoulder should be continuous along the full length of the roadway. So continuous siya if unsa katas ang imong road mo sa nakatas sa imong shoulder. So it also adds structural strength to the road pavement. So shoulder increases the horizontal sight distance on curbs and it reduces accident potentials when vehicles stop during emergencies. So most of the road shoulders in rural areas are unpaved or dili siya sementado. Yeah, it has a width of a 60 to 120 centimeters wide, either earth field or gravel surface, that during rainy days, drivers are hesitant to occupy kay syempre maglapok-lapok man na. The policies on geometric design recommended that outside shoulders should be paved for at least 3 or 3.60 meters wide if truck volume is more than 250 in the design hour or ADT. The recommended width of left shoulder is 1.20 to 240 meters with at least 1.20 meters paved. If there are at least 6 or more lanes, the median shoulder should be 3 meters wide or 3.60 meters if truck volume in the design hour exceeds 250. For arterials with ADT less than 400, the usual shoulder width is fixed at 120 meters minimum, although 2.40 meters wide is much preferred. When the design hour volume ADT exceeds 400, the usual minimum shoulder width is 2.40, although 3.60 meters is also recommended. And for urban arterial roadway or road, similar shoulder without curb is suggested unless needed for purpose drainage. The width of the median shoulder on 4 lanes divided arterials is fixed at 90 centimeters as minimum. For 6 or more lanes, 2.40 to 3 meter shoulder width is recommended. For rural collector roadway, 60 centimeters wide graded shoulder is required for ADTs less than 400. And for ADTs over 2,000, 2.40 meters wide shoulder is also recommended. So, in this figure, muna siya ang shoulder design or mga shoulder details. So, a straight line alignment, shoulder detail with stop lane. And this figure 2 is a straight alignment, shoulder detail with stop lane, guardrail. So, guardrail, muna siya katong muna siya koral sa ali sa kalsada na mo stop sa mga car para dili matagak ang mga car, muna siya koral sa car. So, in this figure, the straight line alignment shoulder details with stop lane used as a cycle path or footpath. So, shoulder detail na naay sideline or naay sidewalk. So, in this figure, this is a shoulder detail with no stop lane, no footpath, and no guardrails. So, this figure shoulder detail is for footpath only. And the last figure is alignment in curve shoulder detail. So, naidwa ka ani. So, inside shoulder and outside shoulder. Sa outside shoulder kay paved or cementado, and the other one is stabilized or treated surface shoulder. So, the next topic is the cross slope, which will be discussed by the next reporter.